Hello students, today we will learn about the intrinsic semiconductors. So semiconductors are basically classified into two types, intrinsic and extrinsic semiconductors. Extrinsic semiconductors are further classified into two types, n-type semiconductors and p-type semiconductors. Intrinsic semiconductors are called pure type of semiconductors, whereas extrinsic semiconductors are known as doped semiconductors. So today we will see the details about the intrinsic semiconductors. So first of all, we will see the key points related to the intrinsic semiconductors. The semiconductors contain no impurities. It means the pure type of semiconductors are known as intrinsic semiconductors. The charge carriers in the intrinsic semiconductors are only produced by the thermal breakdown of covalent bonds. Okay, this is the important points regarding intrinsic semiconductors, and the conducting properties are the characteristics of the pure or intrinsic type of semiconductors. And absolute zero temperature, that is 0 degree Kelvin, the intrinsic semiconductors act like insulators. And the famous examples of the intrinsic semiconductors are silicon and germanium, etc. So now we will see the example of intrinsic semiconductor. So I have already quoted two examples, like silicon and germanium are famous intrinsic type of semiconductors. So we will see the example silicon crystal at 0 degree Kelvin temperature, means at absolute zero. So we know that the silicon has four valence electrons, four electrons in the outermost shell, as the atomic configuration, okay, of silicon is 2, 8 and 4, as the atomic number of silicon is 40. So 4 electrons are present in the outermost orbit. It means that the 4 valence electrons are there. Suppose this is a silicon atom and these are the 4 valence electrons. So consider another neighboring silicon atoms having same 4 valence electrons. So this is also a silicon atom. Okay, they are placed nearby one another. Okay, now these two silicon atoms, nearby neighboring silicon atoms, share 2 electrons and form covalent bonds. So suppose this dash line dash, this ellipse is nothing but the covalent bond between these two silicon atoms. So there are many covalent bonds inside the silicon crystals. Okay, and each valence electron in the silicon crystal is associated with the covalent bond. It means that no electrons are free inside the silicon crystal, and each electron is associated with the particular atom. It means that each electron is bounded to the other atom. So hence the silicon act as an insulator. It means intrinsic semiconductor act like an insulator at 0 degree Kelvin, because no electrons are free in this structure or in this silicon crystal structure. But when the temperature increases from 0 degree Kelvin, when temperature is greater than the 0 degree Kelvin, it means that this silicon crystal will be thermally activated when temperature is 0 degree greater than the 0 degree Kelvin, and because of that thermal energy, these silicon atoms, okay, vibrate about its mean position. So as the silicon atom is vibrating about the mean position, it means that whole crystal is vibrating about the mean position. So I am showing the animation. Suppose this silicon atom is vibrating about the mean position because of the thermal vibration. The whole crystal is vibrating about the mean position, and because of that thermal vibration, that thermal energy, these electrons will be taken thermal energy. It means thermal energy will be taken by those electrons, and and because of that covalent bonds get broken and the electrons are released from this covalent bond. Suppose this electron is releasing from this covalent bond, and suppose this electron is releasing from this covalent bond, and the absence of electron is there at this position. So absence of electrons, it means that the empty vacancy is created here, quantum vacancy. So that vacancy is called hole. So holes are created and these electrons become free from this silicon, free from this covalent bond, and these electrons are known as the free electrons and they are able to move throughout the crystal. So these electrons, these free electrons, are responsible for the conductivity in the silicon crystal, means in intrinsic semiconductors. So this generation of free electrons which are responsible for the conductivity. Okay, so charge carriers in intrinsic semiconductor, when the temperature is greater than 0 degree Celsius, the charge carriers are electron and holes. So this is the phenomena of creation of conductivity, or this is the phenomena of generation of conductivity in this intrinsic semiconductor above the temperature 0 degree Kelvin. Okay, so I am quoting some important points. As the temperature increases about absolute zero, each atom of semiconducting crystal vibrates about its mean position, and some of the electron acquires sufficient energy and covalent bonds get broken down. Then electrons will be free, and those free electrons move inside the crystal, resulted in the electronic conductivity. As number of free electron increases, the resistance of semiconductor decreases. It means when the number of free electron increase, the conductivity will increase, hence the resistivity will decrease. So these intrinsic semiconductors have negative temperature coefficient. What is negative temperature coefficient? When temperature increases, resistance decreases. So this property is called negative temperature coefficient. So these intrinsic semiconductors have negative temperature coefficient. Okay, so now we have quoted some important points and charge carriers in intrinsic semiconductors. So electrons and holes are the charge carriers. So when intrinsic semiconductor, for example silicon, when covalent bond get broken, the electrons is set to free and they are responsible for the conductivity. These free electrons are one of the charge carriers in intrinsic semiconductor. Second charge carrier is hole, because as the electrons become free, there is a generation of positive quantum vacancy. That positive quantum vacancy is nothing but the holes. It means the removal of one negative electron leaves a quantum vacancy of effective positive charge, that is known as hole, and plural form of hole is holes. Okay, now the electron hole pair. Okay, as one covalent bond is broken, the one electron becomes free. Simultaneously there is the creation of hole. Okay, it means one hole pair is generated as the breaking of one covalent bond of an atom creates one electron in hole. Simultaneously this is nothing but the electron hole pair. And one more phenomena takes place while the generation of the charge carriers, that is nothing but the recombination. It means that in intrinsic semiconductor, when temperature is greater than zero, a free electron moving random inside the intrinsic semiconductor, it means that electron may encounter with the hole, then combines again with the hole to form electron hole pair and thus the covalent bond. So this process is nothing but the recombination. Again I am quoting that picture, on I am showing that picture. When this electron is free electron, when this electron is moving inside the inside this silicon crystal, it may sometime encounter with the hole, so it again combine with that hole. So this process is nothing but the recombination. So recombination can also be takes place in intrinsic semiconductors. Okay, so these are the details about the intrinsic semiconductors. So we have seen in what are intrinsic semiconductors, what are the example, what happen at 0 degree Kelvin and above 0 degree Kelvin, and we have seen the generation of charge carriers and what are the charge carriers and processes happen inside the intrinsic semiconductor. So today's that's all. Now in the next lecture we will see the energy level diagram for intrinsic semiconductors. Thank you very much.